All right. Hello, everybody. And thank you for having me on today. And today we are going to be looking at the question of why is OAuth hard? What makes it difficult here in 2024? First, though, we've really got to get down to the question of what exactly is OAuth in the first place. Before we can ask why it's hard, we need to know what it is. So OAuth is fundamentally a delegation protocol. It's something you can use to allow API access for a piece of software, but most importantly, on behalf of a user. In other words, we've got a person here, which OAuth calls the resource owner, and they've got access to some set of things that are behind an API. They've got a user account. Maybe this is their calendar or their photos or medical records or really anything. And they have a piece of software that they want to access that API on their behalf. And so the goal is to give the client access. This is going to be all about this bottom arrow here. This is what we're solving for. So historically, we've solved this in a whole bunch of different ways. This is not a new problem by a long shot. And way back in the day, going back maybe 20 years or so, this was the most common pattern. And that's that we just ask the user for their username and password in the software, and then we'll just play that back to the API. And that way the API just says, oh, this is the user that's logging in, so I know which resources that I can use, and I can let whoever is making this call go ahead and do that. It seems nice and simple on the surface, but it falls apart in a lot of really important ways. First of these is that the protected resource here, that server, has no way to tell the difference between the user coming in and software coming in on that user's behalf, which means that that software can always do everything that that user can do. There's no way to limit it. There's no way to say that this can only read my bank account balance and can't actually make a transaction because the client software is completely impersonating me. Additionally, if that user wants to cut off access to that software, well, then they need to change their password. There's no other way around it because that software has a copy of that user's password and they're playing it against that API. And finally, this is really limiting to particularly insecure authentication technologies like password alone. So you can't use multi-factor authentication. You can't use federated authentication. You can't use anything that we're doing with user accounts today because the software needs something that it can copy. Another option that we see a fair amount of is just using an API key. So we give the client universal access to the API and tell the client, you know what, when that user shows up, you just tell me that that user is the one that you're acting on behalf of. In order for this pattern to work, you really, really, really have to trust that client software because it can effectively impersonate anybody on the system. Now, it's a way to limit the access of a particular API call, but you're giving all of the power of that limiting function to the piece of client software. And so this doesn't work at all when you start to think about mobile applications or single page web applications or anything of that nature, where the client software is out of the control of this highly trusted backplane where your resources live in the first place. OAuth gives us a solution to all of this problem by adding in a couple of key components. The first of these components is the access token. The access token represents a delegated set of rights that says that this piece of software can do these things for this person. And so it limits what that call can do. Any call with this access token can only do the things that that access token is good for and nothing else. And that set of limitations is hugely empowering both in the design of the API and also what you can start to say about the clients and the systems. Now, there are a bunch of things we could do to get these access tokens. We could tell users, oh, go to a portal and click a button and copy a value into your client or, into whatever application you're using. Or we could, invent some like courier mechanism to get this across the wire. OAuth does this, though, with the authorization server. The authorization server is a dedicated component that enables security for the rest of the system. And it does this by authenticating the users, authenticating the client software that's making these requests, and also by issuing these access tokens, because the authorization server is in the unique position to be able to pull together that tuple of information. It's this user, it's this software, it's this API that's being called, and pull that all down into the access token. So down at the resource server layer, down at that protected resource, all we care about now is, what do I do with this access token? Is it good for the call that's being made? Which set of medical records do I return? I can get all of that information from the access token without having to know the user's credentials or validate the clients or anything like that. OAuth is absolutely everywhere. I guarantee you that you've used it. If you logged into a Google account to get to the meeting today, that is all based on top of OAuth. Pretty much any large-scale web API, just about all mobile applications that use services that tie to some sort of back-end system, and nearly every single smartphone uses OAuth in its internal operating system in order to connect it to various cloud services. OAuth is absolutely everywhere. And the truth is, if you're a developer working on the web and on web APIs and related things, you've probably programmed using OAuth. If you've ever had to get a token to call an API, chances are that was OAuth. If you ever needed to log into a site, but in order to do that, you had to redirect somebody somewhere first and then they came back, you were probably doing OpenID Connect, which is built on top of OAuth. Or you've had to parse a JSON web token or some other token format in order to process your API gateway. Chances are all of that is very likely built on top of OAuth. So OAuth is everywhere, absolutely everywhere today. So why is it hard? It's 2024. The OAuth 2.0 standard was ratified in 2012. Why is it still hard today? Well, we actually have to ask the question, is it hard? Right? Because if you've built OAuth applications, you may not have thought that it was all that difficult. It might have seemed pretty simple and straightforward. Well, the truth is that this is probably the part of the system that you've worked on. More than likely, you were building out an OAuth client to call some sort of API. So you were getting access tokens and you were using them on an API. Or perhaps you were building the API that was protected by OAuth, and you needed to validate the tokens and figure out the calls coming through. Or maybe even you used OpenID Connect, which is a more complicated protocol, but it's one that's fundamentally built on top of OAuth, where you're getting access tokens and you're calling APIs and you're getting user assertions and all of these other bits and pieces. So if you're looking at it from any of those perspectives, OAuth might actually seem relatively simple. But here's the tricky part. Where does that authorization server come from? This is where the complexity lies, because it was a deliberate design decision with OAuth and OpenID Connect both, that wherever possible, we would push the complexity away from the client application, away from the resource server, and onto the authorization server. That means that anywhere that there was a decision in designing this protocol and its set of common extensions, any place that the AS can make a decision instead of the client, then the AS makes that decision. Right? So take a look at an extension like Pixie. The client goes and just sends values. It's the AS that has to actually validate those values. The client might not even be able to check all of the the hashing and verification that needs to happen there. It's up to the AS to make sure all of those pieces are in place. The OAuth landscape as a whole is immensely complicated. Sure, we've got just sort of a core specification, this RFC down here, RFC 6749, that defines the core of the OAuth protocol. But there's a lot of decisions within that protocol and also a lot of stuff that builds on top of it. And this diagram is a few years out of date, quite honestly. This has grown significantly in the last 4 years or thereabouts. Some of these are now RFCs. There are more extensions that are being built out, more applications. And this is a huge decision space that you have to navigate. But the thing is, when you're building an OAuth client, you're usually given a path through that maze. You're not usually given a lot of choices. You're told that, oh, you're calling this API and you're this kind of client. Well, I need you to make this call first with these parameters and this secret that I'm going to give you. And then I need you to make this call and this. And now you get an access token and here's how to use it. You don't get to pick the options. The system that you're interacting with, the system that you're integrating with, picks those for you. And so because of that, the complexity is drawn away from the client. If you're building the authorization server, though, you need to deal with this entire space. All of this and any additional customizations and sort of local considerations all need to be considered as part of your application as you're building things out. The reason that this complexity shift works so well is that we expect there to not be that many authorization servers in a given ecosystem. Quite frankly, you usually only see one, maybe a couple authorization servers within a given system, a number of protected resources, and then a lot of different clients. Because the clients, that's where people are coming up with interesting and new ideas and new ways to use the data that's provided by the API. And that's really the focus of the client, isn't it? It's to use the API. The focus of the client is not on the security platform. The security is what the client has to do in order to get access to the API. And similarly, the APIs themselves, those are not dedicated security components so much as they are providing a particular service. It's providing medical records or bank information. It is trying to offer something that is valuable. And security is an important way to protect that and to enable connection with that. But again, here, it's enabling that API to exist in a wider system. The authorization server is different, though. The authorization server is a dedicated security component. That is its only job, is to manage the security of this overall ecosystem. So it makes sense to have this place of concentrated expertise in the authorization server instead of a system where if any one of these nodes gets broken, it cascades through everything else. Which, if you look back at the password-based API access, that's what you end up with, isn't it? You get one compromised client that can then exfiltrate that password to an attacker. That attacker can now go after the entire system. It can go after all of the different APIs and accounts and lots of other things that password was protecting, all because it was exposed to one bad client. In an OAuth-based system, all of the clients are limited to only what that client can do, and they can be shut off and managed individually. So we need an AS. So let's make one. So there are a few different approaches to this. You've got an AS that you want to stand up. The first, make it yourself. How hard can it be, really? Well, you may guess from the name of this talk that it's actually really, really difficult to properly make an AS, but it's not impossible. And in fact, there are a lot of really great open source projects that you can build on top of, and you can deploy that. And this means that you're running it in your own space. You've got control over all of the user accounts. You've also got control over all of the security artifacts and all of the flows and everything like that. So no matter whether you're building it from scratch or building it on top of an existing project, you're responsible for everything. And this approach has some really great benefits in terms of, because you're building out the system, you have complete control of all of the data, all of the user experience. Everything happens through things that you can control. You can customize it to do exactly what you want, exactly when you want it. And I'll say again, there are some really great software projects out there that you can build on top of. And a lot of them are available for free for open source. Well, free financially, because as I think a lot of people know, that the cost of open source is in the engineering investment. Because now you have to keep up with any changes, both to whatever software you're running, but also to the specifications and the best practices. You need to figure out, since you're running this dedicated security component now, how you want to support all of those different options, if you want to change anything about those options. And you need to understand how to apply all of these best practices. And if any of this breaks, suddenly it is immediately your problem and only your problem. And finally, you're beholden to whatever platform it's running as. So if you're a node shop and you pull down a Java-based authorization server to build stuff on, well, you better spin up some Java expertise, because that's your choice. That's what you've got to work with. Alternatively, you could go the software as a service approach. And in this approach, you pay somebody else, you pay an expert to go and run the entire system. So anytime that you need to go and have somebody connect an application to an API or whatnot, you send them off to the service provider. They manage the user logging in, they manage all of the OAuth flows, they manage giving away the tokens, and all of that comes back into your environment. This fully hosted software as a service has some distinct advantages over the entirely homegrown system. For one, you're paying experts to keep up to date with all the changes and apply all of the best practices. So if a new parameter comes in, a new extension comes in, somebody else is figuring out what that spec means and coding it into the system. You also have to figure out no longer exactly how to integrate it on a code level. It's more of you're setting up a configuration and tying stuff together. And if this breaks, well, that's what you're paying them for, to go fix it. Like, you're paying for that reliability. But then again, you do have to pay for that, right? It is a higher financial investment because you're paying for this ongoing service. You also get a lot of limitations. You have to, every time your users interact with the system, they're interacting with the hosted system, not with yours. And you get a kind of vendor lock-in here. Even if you're building on top of standards, a lot of times you're going to be integrating with that SaaS's SDKs in order to actually tie things together. And finally, you can only customize it where they let you. So if we go back to that diagram before, let's say that you've got a bunch of customizations that you need to do before and after particular calls. So let's say that the access tokens that you're getting back, you need to decorate them with certain rights. Well, hopefully this SaaS provider has a hook that allows you to do that, and that allows you to figure out how to do that in only the correct circumstances. There is, though, a third way. And that's that you kind of build it so you keep control, but you outsource the hardest parts. And this is what we at Authlete call a semi-hosted architecture. In that you're building the authorization server, you're running it in your environment, but anytime in that application that you're going and doing some part of OAuth, that's when you call the hosted service. And the hosted service says, this is what you're doing next. So somebody comes into the token endpoint, you're not validating those client credentials, you're not validating that request, you're handing it off to the hosted API that says, you know what? I'm going to look all of this up, make sure all of the keys align, make sure that this is a request that this party's allowed to do. And here's the response. I'm going to tell you what the next step is and how to do it. And because this is hosted as an API, this is a lot more flexible than what we showed at the very beginning with just the completely homegrown service built on top of OSS, because you don't actually need to use our libraries. We provide them, and we provide some SDKs, but you don't need to use them. You can actually just call the Authlete API directly with HTTP. And this is a really powerful thing to be able to do. So it kind of combines a lot of the best practices of both build it yourself and have somebody run it. Because all of the hard OAuth parts, they keep up to date with the changes. As the OAuth working group and the FAPI working group and sort of the surrounding ecosystem, which is very extensive, comes up with new changes and new practices, we incorporate those. And so that when that call comes in, we're already applying those pieces of logic to your request. It allows you to have custom coding, but also configure all of the most difficult OAuth pieces. You also completely control the user accounts. So your users never get sent over to somebody else's platform to log in. They're entirely in your environment. So if you've got a single domain, single sign-on already, just use that. It's great. You don't now have to set up a federated account with another service provider just to get people to log in, right? And if you're looking at setting up an authorization server IDP, it's probably not a capability you would have to begin with. And importantly, it lets you customize every single request and response because you control, your software controls what that request looks like to the API, and you control what happens with the results that come back from the API. So you get back a bunch of JSON and you need to augment that with additional data. Absolutely, you can do that. It is under your control. Say that you can detect something in a very specific case that you need to add more parameters in than what the client presented. Yeah, that's easy. That is something that you can detect in your software and customize it exactly how you need to. The downsides of this, and it's not for everybody, is that it kind of is a higher financial investment than if you were to just download something for free and run it. And it's a higher engineering investment than SaaS. But what you get with that financial investment is this world-class expertise that you get with a SaaS. And what you get with the engineering investment is the massive flexibility that you would get with a completely homegrown system. And that customizability is really a major key here. So your code always gets the final say. You decide when you're calling the Authlete API, and you decide what you do with that result. We don't do that. So if you have a whole auditing process that you need to go through for calls, if you have additional claims that you need to set, you have absolutely full control over all of that. Do you have only certain users that should be allowed to federate to certain environments? You can figure that out. Like you can have that logic so that the users that aren't supposed to be doing things never even touch the external systems. And speaking of which, we don't see or store any user accounts. Like all of this user data, especially like your customer user data, we never need to manage that. If you're doing OpenID Connect and you need an access token, you tell us what claims to put in the token. We will create and sign the token and hand it back, and then we forget it. We don't need to store any of that. But then on the other side, your code doesn't need to manage client configurations, doesn't need to manage tokens. You're no longer the target of token exfiltration attacks because you're not storing the tokens. You're not managing that type of data locally. So when does it make sense to have a semi-hosted system? Because I'm going to tell you right now, it doesn't make sense for everybody. It would be really convenient for me to come in and say that a semi-hosted system is always the best idea, and we just so happen to be selling one, right? You should always be skeptical of somebody that tells you that whatever they have is the best idea. But the thing is, I do think that a semi-hosted system makes a lot of sense for a lot of use cases. And these are a few of the key tenets that I think that you ought to look for and that our customers have looked for. First, I've touched this a few times, is control over end user data. The service provider doesn't need to store and manage your user data. If you have a way to log people in, if you have a way to audit accounts and manage account life cycles, you don't need to synchronize with anybody else because it never leaves your system. Corollary to that, the user themselves never leaves your system. You're never sending them over to somebody else. You're never sending them over to an authorization page that's hosted by a SaaS provider. You get to provide what that user experience is so that it looks and feels and fits in with the rest of your application stack. Because the user shouldn't feel like they're using a piece of security software. They should feel like they're making decisions within your system, which interestingly means there's no white label option because there's no labels to change. Authlete runs in the background of some very, very big systems that you would never know it was there. We're very, very happy to just continue to be that backend service. You get to choose your own development platform, something that makes sense in your environment, something that you can support. We've got one fairly large client that builds out their entire system, their entire application stack is in Clojure. I challenge you to find a world-class authorization server that runs in Clojure, right? They're not out there. It's a relatively niche language. I'm probably making all of the Clojure fans on the call, a little upset about that, but let's be real. There are a lot of smaller languages and smaller platforms out there that people really love for very good specific reasons that you're not going to find general purpose tooling in. Because Authlete and the whole semi-hosted platform concept is entirely API driven, HTTP API driven. You can call it using whatever tool suite makes the most sense for you. You get final control over all of your application logic. So if you've got auditing that you need to do, if you've got customization that you need to do, or some area specific specialized concern that is not going to be accounted for in sort of a general purpose security application, we've got you covered because you can absolutely do whatever you need to before and after every single call, even deciding to not make a call to the Authlete API in certain circumstances. But you also, on top of all of this, need standards compliance. Your applications and your customers should not be integrating with Authlete. They should be integrating with you. They should be building to your platform, to your system that uses internationally recognized and well-designed open standards like OAuth and OpenID Connect and the family of protocols that surround them. That means that the people that are building up against your system can pull a library off the shelf and have it work because your system is speaking the standard language that the rest of the world is using. Which means that the clients calling your APIs can focus on the API and not the security layer. And that your APIs can focus on providing the best data that they can. While your authorization server can focus on being the integrated component of this, but the hosted portion of this, the service, makes sure that all the things that you do are compliant with the standards. Because you want to focus on your application. Your goal is to deliver something amazing. But to do that, you need the best security that you can apply to that. Authlete offers this as a service. You build and run the AS yourself. You can run it with any language that you like. And you only call it when you need it. And finally, your users never actually see Authlete. It's all your environment. It's all your system. That's what's in the foreground. And that's the part that matters. So thank you all very much for listening. And I am happy to switch to taking questions.
Thank you, Justin. And thank you, everyone. So it's time for questions. Don't hesitate to write them from the Q&A tool or chat, or just open your mic and ask a question. At least I had one that I wrote in the Q&A tool. I asked if it exists as certifications or like badge, I don't know, that assure that the service used like Authlete is OAuth 2 and OpenID compliant.
Yeah. So for OpenID Connect, there is the OpenID Foundation, which controls that standard, has a certification suite. And Authlete's engineering team is actually directly involved with the certification team at the OpenID Foundation. And so you can basically be you can take your system and run it against a bevy of tests that say whether or not you're compliant with that. There's nothing out there that is specifically for OAuth, because OAuth has kind of a wide protocol space with all of those different boxes that we were showing before. That you would have to pick a certain set of paths that you're testing against. So nothing like that quite exists for just OAuth. But for OpenID Connect, which includes OAuth functionality, there's the OpenID conformance certification, which Authlete is nearly always one of the first to get conformance whenever a new profile is added to the system. In fact, we actually run the OpenID Foundation conformance suite as part of our CI/CD pipeline. So any new release that goes out has been very thoroughly and regularly tested against that for conformance.
All right, thanks for the answer.
All right. How do you envision the future of OAuth? That is a very wide question. So I think that it's really going in a couple of different directions. First is the space that OAuth has kind of already carved out for itself on the internet, and that I see continuing. Applications accessing APIs on behalf of users, that kind of thing. I really see that continuing because we're still seeing API-driven spaces. We're still seeing application and API first types of workflows, and I see that continuing. But there's also a lot of effort sort of around the edges of the OAuth and OpenID space that's looking at how we can bridge to new technologies. So, for example, there's the OpenID for verifiable credentials, issuance and verification and presentation work that's happening right now. And that's basically using OAuth and OpenID to present a different type of credential called a verifiable credential. If you've heard of mobile driver's licenses and things of that nature, that's really what's happening here. That's the kind of thing that's at play here. So when you go to present a digital mobile driver's license, there's possibility that what you're actually doing is an OAuth transaction in the background, and it's presenting that license as part of that. There's also work that's happening on sort of extending the concepts of OAuth into other spaces. So a lot of work on, that notion of the API server. I drew it as just a single box in all of the diagrams, but the truth today is that it's not a single box pretty much anywhere. You've got a bunch of little services that are chained together to actually answer those types of requests. Well, OAuth gets you to the doorway, and a lot of the assumptions in OAuth start to fall apart when you go inside. And so there's a lot of work that's happening right now about, well, how do we sort of bridge these two worlds? How do we connect these spaces so that I know that the path that I'm going down is the correct path, and I'm still giving back an answer that makes sense to the client on the outside? So I see a lot of space for extensions and for bridging into related spaces in the OAuth world. Okay, so question from Antoine. The AS was telling you what to do next after an authentication request. Does it have to do with Helios? Not exactly. So what I was saying is that the authorization server, when powered by a semi-hosted service like Authlete, what happens is when the request comes into the authorization server, it calls the Authlete API, which then says, all right, so here's the response that you give to whoever made that request to you. Right. So it's not exactly just an embodiment of Helios principles. It's a matter of how these different bits and pieces kind of fit together. So you can think of it in a way as if you're building your own system and you need to tie things together. Let's say you're building it on top of an SDK. So the call comes in, you gather all of the parameters, and then you go call the SDK that says, all right, so what do I do with this? What's the next step? Is this an error response? Is this a correct response? How do I format it? What do I do? Authlete is really kind of similar to that, except in order to make that SDK call, you're actually making a call to an online hosted service, which means that that service can be updated. It can have live information about configuration and context and help you actually make that decision in real time based on what you need to do next. It also means that integrating with that piece means that you're not tied to whatever language or platform that SDK and library was built on top of. What is the complexity and size of an infrastructure for Authlete server and to serve company and apps
Service. Right.
worldwide? Yeah, Sasha, do you want to? Is there anything you'd like to?
Yeah, I made a typo, like for Authlete service, I would say, not server.
So we serve all different kinds of customers, everything from like very small sort of point integrations. People just need sort of like a little bit of thing to go do FAPI integration, which is the financial grade API at the OpenID Foundation. Do that type of integration on top of an existing system, or they need to tie into some type of, they just need a federation endpoint on top of an existing infrastructure, all the way to we run the entire sort of API access and federated identity portion of identity stacks to some really large companies. There's some of our customers who, a bunch of you probably have gone through their accounts, but because of the nature of our system, you would never know that it was Authlete. And because of business reasons, I can't just list everybody right now, but they're very, very big. One of my favorites, though, is that we have this one media company in Europe that hosts they do the voting system for a game show. And every time one of these broadcast events comes up, they basically contact us to scale them up for the duration of the event and then scale them back down because they are going to go suddenly from, a couple of things here and there to millions of people all at once and then tail back off because everybody's put their vote in for their favorite singer or whatever. Because Authlete is like natively cloud-based, because it's service-based, we can offer that type of scalability in this is your regular software as a service type of argument, except that we're only dealing with a very specific piece of the stack. So we're dealing with scaling the security component, and we're not getting in the way of sort of the rest of the scaling that a company like this would need to do.
Okay, thank you so much. At least I have another question related to the one you answered.
Sure.
Do you recommend a host or a cloud provider for this kind of service, or you are self-hosting your service for clients?
So for the Authlete service, we're flexible. We're happy to host it for you in either a shared or dedicated environment. We also have some customers that host it in their own cloud environments. Those are different contract tiers. but we're flexible in how we do that. It's built in such a way that we're not tied specifically to one cloud environment.
Okay.
And you can go and get a free Authlete account to try this out if you want. There will be links in the show notes to this. Also, want to encourage folks to, we've got a beta for the new version of Authlete that is available now. And you can see some of the new features that are coming down the pipe in the product. And so we should have all of that information available for people to get to at the end of the show. And it's free to try out. Play around with it, set something up, and see what you can do. All right.
Any other questions? I think not. So I will stop the recording right now.
All right. Thank you all very much for having me today.
Yeah, thank you so much, everyone, and thank you so much, Justin, for your presentation.